Bright QT. Every student matters.
Now, based on the number of carbon atoms that can be attached before the functional group, we study the homologous series. Now, homo means same. So, homologous series means series which look the same. That is to mention that series in which the functional group is same, but the number of carbon atoms vary. So, for example, there's a chain of 2 carbon atoms and there's a OH in the end. What if there's a chain of 3 carbon atoms and there's an OH in the end? What if there's a chain of 4 carbon atoms and there's an OH in the end? All of these will be called alcohol. So these series, these group of compounds which have similar functional group attached to them but differ with each other by a multiple of CH2, because more carbon atoms get attached and they have 2 hydrogen atoms attached to it. So they differ by 2 things. They differ by CH2 and they add 14 AMU, that is atomic mass units. So they differ by 14 atomic mass unit each, like one after the other, and they keep on adding CH2 in it, and that is how, and these series are called as homologous series. As you go down a homologous series, for example, if you go from ethanol to methanol, as you go from a ethanol to propanol to butanol, as you go down the series of alcohol, you will see that some properties are common. The chemical properties are common, but the physical properties show some gradation. The melting and the boiling point increases with the increase in the number of carbon atoms. So we have understood that the melting point and the boiling point increase as we increase the number of carbon atoms, but the chemical properties remain same. Right? So based on the functional groups, we have homologous series which have an addition of CH2 in the same functional chain of carbon atoms, which also has 14 atomic mass unit of weight, and the chemical properties are same along the series, but the physical properties show some gradation. The next topic that we'll be doing is nomenclature. Before we move on to nomenclature, let's just revise what we have done so far so you can understand what are the elements that we will be naming today. So we understood that carbon exists all around us in different forms. It forms many compounds with elements, with different elements because of 2 properties of catenation and the property of tetravalency. It also exists in free forms of diamond, Buckminster fullerene and graphite, but we'll not be naming them because they are pure carbon. What we will be naming are the compounds of carbon. Compounds of carbon have the first option of being pure hydrocarbon. Hydrocarbon are also saturated or unsaturated. Saturated would be alkane and unsaturated will be alkene and alkyne. Again, then there can be an heteroatom added to it and then it will be called as a functional group. Based on the heteroatom added, there are different names for functional groups. If it is a halogen that is added like chlorine, bromine, iodine, fluorine, then it is called as chloro, bromo, and so on. We'll do that later. And if we add oxygen, then depending on how oxygen is bonding with the carbon atoms, there are different possibilities. It can be alcohol, it can be ketone, it can be aldehyde, and it can be carboxylic acid. So this is just a rough summary of what we have covered so far. And now we will try to name these compounds based on our understanding. So IUPAC is an organization which universally decides how carbon compounds will be named. So it has laid certain rules, and based on these, there's a universal nomenclature for all carbon compounds. The first thing that we have to do is find the longest chain of carbon atoms. So see here. Right? So you might think that this is the chain that we have to talk about. This will be 1, this will be 2, and this will be 3. But no, this is actually the longest carbon chain. It is 1, 2, 3, 4, 5. So we have to spot which is the longest carbon chain. And sometimes it seems a little tricky because we are bound to see this row which is laid in front of us and we do not see the branches. So we have to find which branch forms the longest chain. Right? So here, this will not be the chain, rather this will be the chain. So we consider the longest chain for naming a hydrocarbon or a functional group. We find the longest chain no matter how many branches are there. So even if there are 4 here and there are 4 here, in this case you can choose either. It will not make a difference in the name. But when there are 4 or 5, then you have to choose the one with the longer chain. right? So first we find the longest chain. Then we indicate the number of carbon atoms with a prefix. The prefix here implies meth, eth, prop, and so on. Right? So for 1 we use meth, for 2 we use eth, for 3 we use prop, for 4 but, for 5 pent, for 6 hex, and so on. So you choose the right prefix for the number of carbon atoms in your chain, not the ones in the branch. So for example, this is the structure that I'm considering. Now this is my longest chain and I will use the prefix for the chain. This is very important. Don't use prefix of 4 here. You'll use the prefix of 3 prop here, right? Because you only consider the number of carbon atoms present in the chain of which you are talking about. Then you add the suffix "-ane", "-ene", "-ine", "-ol", "-al" based on the group which is attached. So you already know that "-ane" is for alkanes, "-ene" is for alkenes, "-ine" is for alkynes, "-ol" is for alcohol, which is an OH group. "-al" is for aldehyde, which is a C double bond O and a single bond with H. Oic acid is for a COOH group. ON is for ketone, so ON is for this kind of carbon atom, right? And chloro is when there's a chlorine atom attached in the end. Bromo is when there's a bromine atom attached in the end. If there was a fluorine attached, then it will be called as fluoro. If there's an iodine attached, it will be called as an iodo, right? So you choose the suffix based on the functional group to which the chain belongs, and also keep in mind that if there's a functional group, you'll be using the suffix of the functional group and not be using "-ane", "-ine", or "-ine", right? Now we go on considering the position of the double bond or the triple bond. Let's see. So here are 4 carbon atoms. Let's make it 5, right? So here there's a possibility of an OH here. Now if I attach an OH here, I can say that the OH is attached on 1, 2, 3, 4, 5. So the chain is 5. I know it is called as pen, and because it's a pure chain, I'm calling it pentane. Now I can say that the OH is attached on the 4th carbon atom. But you have to keep in mind that you have to start numbering from the end, which will give the functional group the smallest number. So you will not name it like this. Rather, you will start from here. This will be 1, 2, 3, 4, 5. What happens here is it becomes 2 pentanol. It is not 1, 2, 3. It is not 4 pentanol. So we have 2 options here. We can start naming from this end or from that end. But you start naming from the end, which gives it the lowest position, the lowest number. So here I'm giving it the position of 2 and not 4 because we want to reduce the position of the group. Same happens with double bonds also. So in this case, I can start naming from here, and then it will be 1, 2, 3, 4, 5. Or I can start naming from here, it will be 1, 2, 3, 4, 5. Which one will I choose? If I choose it from this side, then the double bond will be on the third. So it will be called as 3-butene, right? But if I start naming from this end, then it will be called as 2-butene. Now which do I choose? I choose the smaller one. So 3-butene is not what it will be called. It will be called as 2-butene because you have to consider the position of the functional group or the double or triple bond, and you have to reduce its numbering as much as possible. Yeah, so the first thing that we talked about here was that when there is a branch of an alkyl, you do not call it, you call it prop. So you don't call it 4. Now how does this branch get its name? This is what we'll be dealing with here. So for example, here's the chain. It will be called as propane, right? But on the propane, there is an alkyl group present of 1 carbon atom on the second one, right? Because this is 1, 2, 3. Even if you start from here, it will still be 1, 2, 3. So it doesn't matter how you start your numbering. It is always on the 2. So on the 2, what is present? 2 is present a meth. So 2-methyl. So you use the suffix of YL to indicate a branch of carbon that is present. If it was 2, then it will be called as ethyl. If it was 3, it will be called as propyl, and so on and so forth. Right? So you indicate the branch separately. Now here it is called 2-methyl propane. It is not called as a butane. So it indicates 1 carbon is indicated here and 3 carbons are indicated here. The person who reads the name below that there are 4 carbon atoms, but still we will not call it as a butane. Now let's go back and name the isomers that we studied before. Right? So this was the first isomer that we studied. This was N-butane. This is normal butane, so there's nothing much to add here. But the other option that we had was this. This is what we just studied. That in this case, this isomer, the scientific name of this isomer, although it's called as isobutane, the scientific name will be 2 dash. You always put a dash after the number. Ethyl, 2-ethyl propane. Now let's try and name the pentane. So this one is called as pentane. There is no N when you are talking of Isopic naming. So N-pentane, isopentane, neopentane, these are names given to the isomers, but they're not part of the Isopic naming. In Isopic naming, this will be called as pentane. Now what will this be called? It's a four atom chain of carbon atoms, and we will start naming from this side and not from this side because we want to reduce the positioning. So it will be called as 2-methyl pentane. 2-methyl pentane. Now this is a tricky one. Here there are 2 branches present on the same carbon atom. How do you label that? So let's see how we do this. It's a chain of 3 carbon atoms. So I know that the word I'll be using here is prop. And since it's pure single bonded carbon atoms, it will be ane. Now there are 2 chains present. So you write 2, 2 dash dimethyl. I'll just write it again. It is called as 2, 2 dash dimethyl pentane. Right? So it's a 2,2 dimethyl pentane because 2 methyls are attached on the same position of 2. If, for example, an ethyl was attached, then it will on like here, if there were 2 atoms attached, then it will be called as ethyl. But since there are 2 different methyls attached on different branches, it will be labeled as 2,2 dimethyl pentane. Dimethyl because there are 2 methyls. What is their position? Both are present on the second carbon atom. So these indicate the position of the methyl groups, right? Yeah, so let's do 2 examples to understand IUPAC naming. So you can either be given a structure and asked to name it, or you can be given a name and asked to draw it. It's 1,2-dichloropropane. So first I will go by prop. It says props, that means I have 3 carbon atoms. It's ane, that means they are single bonded. There are 2 chlorines present on first and second position. So this is my first, I attach a chlorine here. This is my second, I attach a chlorine here. So there are so I've covered the part of 1 and 2. I've satisfied for the 2 chlorines, and it's a propane. Now I attach the remaining hydrogen atoms. So whatever the remaining positions are, you fill it with hydrogen. And this is my structure of 1,2-dichloropropane. Let's try another example of 2-methyl butane. Butane hai, so it's butane, so we will be using 4 carbon atoms in the main chain. There are on the position of 2, there's a methyl, and you fill the remaining with hydrogen. And this will be structure of 2-methyl because it's present on the second carbon atom. A methyl group is added, and that is how 2-methyl butane will be drawn. If it was 2-ethyl, then here instead of writing CH3, I would have written C2H5, right? That would be for ethyl. So this is the Isopic naming. You'll need to practice Isopic naming on different elements, but you just need to keep in mind few things. At first, you have to find the longest chain. Second, you go on understanding what is the functional group. You choose the suffix and the prefix. If based on the number, you will decide if it's called prop, mate, eth, etc. Of number of the atoms in the main chain. And if there's a functional group in the end, is it if it's carboxylic acid, then you'll use oic acid. If it's alcohol, you use all. If it is an aldehyde, then you'll use Al, and so on and so forth. And then you position the different things which are present on the branches, indicate them by a number. You do not use any capital alphabets here. Capital alphabets are a no-no. And you indicate the position by a dash. And if there are more than one thing, then you use a comma. So like 1, comma 2. And what are the elements will be mentioned here. And then there comes the number of carbon atom and then the type. Okay, so that is all for Isopic naming.